tell about how the query optimization happens and how the selectivity estimation is important here. And we're gonna talk about the best practices in Postgres security. Then our next speaker is gonna delve into security more. So here are the key topics we're gonna discuss: selectivity estimation in Postgres and how to balance performance with security in Postgres. So query performance, as we know, it is for better user experience and to maintain strong security. We concentrate on protecting trust and sensitive data, and we should acknowledge that both of these are equally important here. Not only performance, not only security, both are equal. So selectivity estimation. The term itself means that it aims at estimating the number of database objects that are returned when we are doing a query. There are existing technologies, existing methodologies that use, for example, heuristic approaches or histogram approaches, and sometimes they lead to performance issues. They lead to suboptimal execution plans. So how this optimizer works itself? It is based on histograms and statistics. It's mainly the values in the where clause that is included in the query. Most of the times it assumes that the distribution should be a uniform distribution. This is the key where it lags, because not always it is true. Not all the queries return uniform distribution, and it mainly uses analyze. It is mainly based on statistics that inside of this server happens. When the resulting statistics get back to it, the executor executes the code and gives us the result, which is coming back to us. As I mentioned, the existing techniques rely on heuristic approaches, which is not very reliable because it works for one-dimensional cases, and in case when we have multi-dimensional cases, it mainly uses multi-dimensional histograms, which sometimes give us accurate estimates, selectivity estimates. However, it requires a lot of memory. Some approaches include machine learning. For one-dimensional cases, it uses linear regression algorithms, but for multi-dimensional cases, there are two approaches. It's either neural networks or tree-based ensembles. Again, this works for non-linear cases, however, it requires lots of memory. Whenever the selectivity goes wrong, meaning it requires more memory or it doesn't give accurate estimates, this happens because of, let's say, one case can be skewed data. As I mentioned, it assumes that the data is uniformly distributed. However, when we have skewed data, the whole program crashes. Another case is when we have multiple correlation and it is ignored. For example, in one-dimensional case, it is treated as one-dimensional, and it can be as linear regression with linear regression model. And in such cases, the correlation is ignored, of course. In the end, poor estimates give us bad execution plans. The approach that I worked with as a program was based on machine learning neural networks. We ran multiple ML models and tried to get the best performance. I'll get into the results later. So what we did multiple query generation, and imagine we had lots of queries which involved multiple predicates. So we excluded one-dimensional case, because for one-dimensional linear regression works fine, so we were concentrating on multi-dimensional. We constructed a query workload by generating queries with dimensions varying from 2D to ND. Yeah.
Sorry, what do you mean by multi-dimensional? With underlying data, what has multiple dimensions in, for example?
So dimensions is based on the, let's say when we are writing a query and we are writing select something from somewhere, it is one dimensional case.
When we join tables, so we get
Yeah, for joint tables we get multidimensional, and for the predicates when we are using where clause and giving it multiple conditions, that is becoming a multidimensional query.
well, definition of multi-dimensional query, what do you explain this?
Yeah, this is the whole picture, like how the program works. The system catalog, it gets to all of these statistics and it gets it to the optimizer, and the optimizer is doing plan generation or end-to-end cost estimation. We also included the existing technique of API, which is a known technique which is used by let's say all of the other techniques, and it is assuming that all of these variables, all of these values are independent from each other. These two plots show us that distribution is not uniform. In this case, we have a 45-degree reference line, and it indicates also the departure from normal distribution as well. In this right figure, we have values which are mainly concentrated on 0, which is revealing a pattern, and we ran a correlation matrix which indicates that all of these variables are almost independent. There are little values 0.23, which indicates that they are independent from each other. Our resulting model was based on these values, shows that the best model choices are decision tree and random forest. However, there is a possibility of overfitting, which should be considered later. We didn't concentrate on that much. But our conclusion was that accuracy of the selectivity estimation is crucial in the query optimization technique. If there are any questions for this query optimization, we can discuss it now.
I think it's very difficult to integrate.
Yeah. That's why this was mainly based on academic.
I understand the methodology of the research. The models that you use to estimate the accuracy are neural networks, I think.
Yeah, there were neural networks and...
Which model was reference model? NN or graphs?
Well, we tried both of them, but
Which
neural networks didn't work quite well.
What was the second one?
We used random forest.
Well, so you fix the query, or you try to run it on different queries. I mean, you fix the query, run multiple times. How do you get the data? How do you collect the data?
Yeah, we generated multiple queries on our data. We had 3 main data sets on which we generated multiple
Data sets, you mean tables?
Yeah, 3 different tables, I
Well,
would say. Yeah.
and you executed multiple combinations of queries.
Yeah. And then we ran our model on already existing queries. Like, imagine the first step was getting the data sets. The second was generating the queries based on those data sets. And then when we have all of those queries in a list, the model runs on that queries, on that list.
Great.
Well, as important performance is, I think more important is securing our databases, especially PostgreSQL, because most of the people rely on it. But we should start the defense at the depth, starting from the database itself. 3 main things that people can concentrate here is authentication, authorization, and encryption. And PostgreSQL actually gives us the options to do so. So there are three things that we can rely on. Who can access what? Here comes the authentication itself. We should use the roles and least privileges principle when we are giving people access as a user, not everyone giving admins. We can configure authentication here, and we should avoid defaults and trust methods because sometimes defaults get changed, and we cannot really rely on that. Next, encryption matters because, using SSL and TLS. In these layers, the data is getting transmitted, and this is where hackers mostly try to get in the way. There are lots of encryption techniques, one of which is transparent encryption, but there are third parties as well. And it is very important to encrypt the sensitive columns in the application. For example, when we have multiple columns and one of them is passwords, of course encrypting it will help us because the hacker, when he enters the system, he can understand that it is password when it is not encrypted, but in case of encryption, it is very difficult to understand which one it is. And it is very supportive for people to know what's going on. We say that logging is an important step based on access and queries. When we see the logs where people query stuff as, let's say, taking the passwords or etc., it is very important to see those logs. And monitor them to see the failed logins and strange queries. And yeah, PG audits or some other extensions can support that logging in PostgreSQL. So it is important to strike the balance between performance and security. Of course, some security features slow down the performance, just like I mentioned before, the logging every query or column level encryption. However, it is important to note that we can deal with the slow queries. However, whenever there is a lack of security, all those data can be gathered by the hacker. So in such cases, we should measure the impact and prioritize critical paths, whether we want a better performance or we want better security. And it is recommended to use indexes and policies wisely. So key takeaways here is to understand that PostgreSQL relies on selectivity estimation for query planning. We need to update the statistics and tune for accuracy because having all data or statistics that can give us wrong results can really have query planning in a bad way. And securing with strong authentication, encryption, and auditing is important in PostgreSQL, and we should always balance performance with protection. Some links for today. I really like the SQL injection part because it is very important in databases. And if you do not secure, of course, people can easily use SQL injection for your database. I think that's it. if there are any questions that I can't answer to you, yeah, that's correct. This is because our next speaker is going to delve deep into the security part as well.
It's nice to see you all today. I'm going to share my screen. I'm going to talk a little bit about Postgres security and kind of go through sort of all the different angles and kind of talk through some of the best practices and things that people do in security. I work at Crunchy Data, which is a Postgres services company. We have several products related to Postgres, and I'll talk a little bit about Crunchy in a minute. And so one of the things that we do is a lot of security projects with, in combination with some security agencies, and I'll tell you a little bit about that work. So through my work at Crunchy Data, I've been exposed to Postgres security on a bunch of different areas, and that's kind of where the idea for this talk came from. My job is mostly around Postgres education. We do a big blog about Postgres, and then I have several Postgres tutorials, and I write a lot of documentation for our products, and I'm also a Postgres contributor. Crunchy Data does Postgres products and deployments. We do fully managed cloud, so if you want to deploy Postgres in AWS or in Google or in the Azure cloud, we do that. We also have a data warehouse that connects Postgres to DuckDB and Iceberg. We also have several products that help people host Postgres on premises, like in Kubernetes, or if you're on traditional architecture, we have some products for that too. So there was a very large Snowflake breach that happened last summer. I don't know if you, Snowflake is a data warehouse. Lots of Postgres users, have their data in Postgres and then maybe send data to Snowflake. I'm involved in a technical group in Kansas City, and the day that the Snowflake kind of attack and their big hack broke, I happened to be at a data meetup in Kansas City with somebody from Snowflake, and we were talking about, security, and we were chatting, and then I went to the restroom. So this meetup was at a bank in downtown Kansas City, and when I went to the restroom, I saw the IT closet with a fan and the door propped open and all of their server racks just out there in the world. And I kind of thought to myself, wow, there are so many issues with data security, and that was kind of one of the things that started me down this idea of talking about security a little bit more and maybe just talking about basics. I thought that was kind of funny. So the world of security for Postgres is really big, and there's lots of different terms. I'm going to go through a bunch of them, but I'm not an Apple Watch people, but my family all has Apple Watches, and they're very big into closing their rings every day, right? They're walking, they're standing, they're exercise rings. And when I was thinking about Postgres security, I kind of started thinking about it in the same idea of these rings, right? That you kind of have the code itself, Postgres itself has the code. You've got, the disk, that you're running the actual code on. You've got, where you're hosting it, right? So you're either in the cloud or wherever you're putting your Postgres. And then you've got the user access, right? So you kind of have to secure Postgres from all of these different angles, to really get everything kind of locked up. So that's kind of how I'm going to organize, the overview I'm giving today is sort of those areas. And so the first thing I'm going to talk about is just the Postgres code security itself. Postgres, if you haven't ever been involved in how the actual code kind of gets into the software project, the code starts at a hacker's email list, and then committers actually commit the code to the actual software project. There's a lot of independent code review and validation that people can do after it's inside the code. One of the things that Crunchy Data does for our clients is we do a line-by-line code review of everything going into the next Postgres version. if you're curious about kind of how code gets from an idea to actually in the code base, I gave a talk about this at last year's Cosette, and I had a really small patch get into Postgres 16 and 17, and I just walked through how I got that code in there, and that's on YouTube. Picture-wise, if you've never kind of been a part of how the Postgres code gets, from to the users, there's generally a big public release every year in the fall. We just had Postgres 17 come out last fall, and now we're on kind of the 17.2 and 0.3. Typically, Postgres releases a point release every quarter, and while Postgres 17 is in the public release, Postgres 18 is currently open commits, and then that will go into beta this spring. So there's kind of always a rolling version that's open for commits, a beta version, and then that goes into production. And so Postgres has become pretty reliable in terms of releasing a major version every fall. Occasionally there's a couple out-of-band releases. If you're following Postgres really closely, we just had 2 major out-of-band releases related to things in Postgres 17. There's a bunch of stuff about that on our blog if you're curious. But some of the point version releases will be extra ones. Postgres does a great job of documenting the versioning, and so it'll tell you when the final supported version came out. You should not be on anything older than Postgres 13 right now, and if you're on Postgres 13, you really should be on 15, 16, or 17. Part of what happens in these minor Postgres versions is the software itself that people have found as they use the software. CVEs are what we have for public cybersecurity vulnerabilities. And so these are things that are either known about the Postgres software itself or about components needed to run Postgres, maybe something in Linux, something like that. The CVE world is a very big world. It's part of kind of the security infrastructure. A lot of it is built on some open projects in the US. And so anytime there are CVEs inside Postgres, those can be found in the Postgres docs, and then typically someone has fixed those, and then the fixed point version is released. So making sure that your Postgres is staying up on those minor point version releases is super important to fixing any kind of security issue with the software itself. This is kind of how it's done. And earlier last year in 2024, Postgres became a numbering authority for CVEs. So that means that if Postgres internally finds out that there's a security issue in the software, we can actually number those and then fix them, and then we list those on the major lists so that other people know to update their software. That's an example of a CVE listing. And one of the things I was gonna kind of mention, I don't know if anybody was involved in this or heard about, there was a huge supply chain attack with SolarWinds. SolarWinds is like a monitoring logging software. It's very common in the US. I'm sure it's pretty common globally. SolarWinds had somebody attack the supply chain from inside. They got into the code base. They started creating pull requests in the Git repository for the project. They became respected in the project, and then they slowly started inserting things that actually became major security issues, and they kind of got inside some of the U.S.'s biggest companies and inside the U.S. government through the supply chain hack. There's a ton of Postgres extensions. So in the same way that I've been talking about staying up on your major Postgres versions, staying up on your minor Postgres versions, that's also true of your extensions. And so lots of these things are, have their own security versions and have their own kind of minor. There's also a couple ways that people do a certification of each Postgres version. There's a group in Canada that does what's called a common criteria, Postgres code line by line. Crunchy Data partners with them, and we do a certification with them on different Postgres versions. So if you're curious about that, you can read more about that. So to kind of close your brains on Postgres security, the Postgres code itself is really secured by the community, right? By the people who are viewing it, by the people who are committing it. Review and testing and third-party validation also help kind of secure that supply chain and make sure there's not stuff happening. Any security vulnerability is addressed by updating your major and minor versions of Postgres, and to stay in security, you want to stay on those major supported versions. All right, let's talk a little bit about Postgres for the disk itself and the storage. So when you have your Postgres software, obviously the files that you have that have your data on them are stored on a disk. And so securing that disk from outside attacks is part of sort of your security posture, right? The primary way that is secured is through some kind of encryption. There's a couple different options for how you can encrypt a disk. No encryption is possible, but very rare. Even like if you get if you get a new MacBook, they have on-device encryption. So it'd be very odd to have a disk that's not encrypted at all. You see a lot of just encrypted devices, the operating system itself. You may have heard of doing security kind of reading in Postgres. You'll hear about TDE. That is transparent data encryption, and that sort of encrypts everything. And so an operating system administrator couldn't then decrypt Postgres unless they had the right keys to do it. Postgres TDE is available through a couple different companies as a paid service. It's not currently supported in core Postgres, but that's been discussed quite a few times, and if you're deep into the Postgres world, you'll see a lot of discussion about that. In general, we kind of steer people away from TDE unless you are in some kind of extreme high security environment, like some kind of maybe a government or military use. In general, your on-device encryption or operating system encryption are going to cover you and cover the disk. There's lots of different ways to handle the key management for the certificates. And if you're using a cloud, you can bring your own key and kind of do your own key management. There's a lot of different ways that this works, and it gets a little bit complicated. If you've heard about PG crypto and you've heard about the cryptography stuff inside Postgres, there is an extension that will do encryption of the actual data inside the database. So this is a way that you can basically encrypt the data itself, and so someone who wants to actually query the data or look at it has to have a key to decrypt it. We see a lot of this PG crypto. You can do it in just specific parts of the database. You don't have to encrypt everything. And occasionally you'll see this in like healthcare industries, financial industries, where most of the data in the database doesn't need to have this level of encryption, but there's some kind of field that is there's an extra layer of cryptography on top of the basic disk encryption. The other thing when you're thinking about how you're doing your disk encryption and how you're securing your disk is that if you have a production database, which, let's say you're running your production database in RDS on Amazon, that's encrypted, you feel good about that, right? But you ship your production data and you package that every week for the developers. If you're not doing something to that data to make sure that the development copies and the staging copies are encrypted, you've kind of just basically exposed your whole data database to other issues. If you want to specifically do some kind of anonymizing, like let's say that in your production database you have people's names, people's like identification information, you can use an extension called the Postgres Anonymizer, and that will anonymize columns, and then your developers can work on versions of the database that don't have like personal identifying information in them or some kind of high security information. About making sure that the disk is encrypted, you'll want to make sure that the backups are encrypted with whatever you have. So, don't make a dump file or, make a backup of your database and then leave it on some kind of disk that's not encrypted, because you're kind of leaving yourself open to that too. And just like we were talking about with Postgres, you need to stay on software updates for, whatever operating system you're on. Last year, you guys may have heard about this. One of the Postgres contributors that worked at Microsoft had been doing some testing of Postgres and found a memory leak in one of the underlying utility packages of Linux, the xeutils package, and it was actually a huge Linux vulnerability that somebody found, through Postgres testing. I thought it was really cool. I got to hear, here in America, we have a public radio station, and they did a big story and covered Postgres, and I knew some of the people that were on the national radio program, so that was really cool. So to kind of review the Postgres disk and storage security, encrypt your data on disk, encrypt specific data when you need it, like with PG Crypto, protect your development and backup disks with encryption. If you need to add some kind of extra pieces in your development process, do that, and then keep your operating system up to date. So let's talk next a little bit about the host that you have your Postgres on. Probably a bunch of you have seen the HBA comp file. So HBA stands for host-based authentication. So this is kind of what you might see out of the box, is just which hosts, which databases, which users, and then what addresses are open, and then what method of authentication that user needs to have to authenticate into the database. You definitely don't want to have a database that's set up to allow, any firewall address and trust authentication, right? Which means that you're not requiring any kind of password, you're not requiring any kind of certification. That person is just allowed straight in. If you are working in the cloud, you probably have a little bit more complicated networking instead of just whitelisting individual IP addresses. So when you're in kind of a cloud environment, there's lots of ways to create, kind of private networks. We have a lot of clients that do these kind of virtual private networks where, all of their, application servers and their projects live in one virtual network. You might have a database in a different virtual network, and you might peer those two virtual networks together. There's a lot of ways to kind of create these pretty secure lockdown networks. You never want your database just exposed to the outside world, right? Your database should be behind your application, and external traffic should be going through the application to the database, unless you're a database administrator or you're doing some work in the database directly. For data work that's going in transit, right? So for any data that's going between the database and the application, or somebody querying the database, there's a couple different ways you can do the certificates. You can just kind of do a TLS mode where there's some kind of password authentication. You can do some verification of certificates. So like we allow people to download certificates if they want, and then they would kind of be able to validate the certificates. And then there's a certificate where you can do verifying it on both sides. One of the security agencies, a network monitoring company in America, says that they did a review of 500,000 Postgres servers and only 36% of them were using some kind of cert. I also see that not a lot of people are doing certs. I think in the future we'll see a little bit more of it. So if you're wanting to take that next step in terms of security, doing some kind of certificate validation is a good idea. Some of you may have heard a long time ago about the Heartbleed bug. That was huge here for anyone in cybersecurity, and that was just related to an outdated, unpatched version of SSL. So just like I was talking about with keeping your operating system up to date and keeping your Postgres versions up to date, the SSL version also needs to be kept up to date in case there's some kind of issue with the actual TLS and SSL. Kind of a big picture review of what I talked about for the host and network security. Set up your firewalls, utilize virtual networking, create a network just for your database and your application, so everything is locked down, and then make sure that your data is encrypted in transit, and if you're able to add some kind of certificate verification, that's good too. So let's talk next a little bit about user access. The basic idea in Postgres, and this is true of any relational database, is just principle of least privilege, using some kind of role-based access control, right? So your super user, your person in charge of the database can see everything, but then everyone else is just given access to the things that they need, not anything more than they need. Postgres lets you create individual roles for people, and you can create groups of users. That's also called create role. In Postgres, there's no group anymore. Everything's a role. And then those are roles without a login. So if you want to have, all your accounting team, you just create a role for accounting, and then you add individual people to that accounting role. People do some kind of schema separation, especially if you have a database or an application where you need people to access the database, but not everything in the database. Like you have, customers that need to see only their pieces of it. So schema separation is a huge way you can secure the data itself, and then individual, roles can just see their own schemas. Lots of folks love to use Postgres views. So if you have like your basic table data, right? Someone can look at everything in the table. You can create a view that maybe just has a few of those columns. So if you have someone who is coming into your database to look at reports, or they're coming in to just look at different, you have maybe an analyst, you can create a view for that person, give them just the columns they need, and that way you're not exposing all of the table data to them. And that's a great Postgres feature to use that kind of helps you implement that principle of least privilege. Postgres also supports something called row-level security. Row-level security is where you basically can specify by row in the database which login can access that row. This was added to Postgres around, I think, version 10. It was a big deal in Postgres because people like the military in the US can now use Postgres. Lots of extremely high security environments could use it. Unless you're doing something like that, row-level security isn't the best way to secure things. There's usually a better way to do it, and row-level security has a lot of overhead. But it is kind of an interesting idea, especially for high security environments. We have a little Postgres tutorial site called the Postgres Playground. It's at learn.countrydata.com, and I help with a lot of this. We have a tutorial for row-level security if you're curious about what it is and you just want to see see it and put your hands on it, you can try it. Then we have lots of other kind of Postgres tutorials and little things that are, either Postgres or SQL skills in there. Check that out. Lots of folks, especially in regulated industries like banking, healthcare, and government, utilize the Postgres auditing, and that is for just auditing individual user behavior, right? And so there's lots of settings. You go through the Postgres docs, you can look at how to set up PG audit, and that's a great way to make your database compliant, audit specific roles, make sure you know when a specific role writes to a database or changes table specifications, changes the DDL. Let's talk a little bit about user authentication. There's some really good docs for Postgres user authentication on creating passwords for individual users inside your Postgres. You're typically going to be using the Scram SHA-256. That is a way of hashing a password, and that's kind of the standard way that that's done. If you just go into your Postgres database and you say, create role Elizabeth, and here's the password, if you're doing the PG audit, if you're auditing the things that are coming into the database, that isn't a hashed version of the password. Postgres has a little bypass where if you do a create role and then /password for the user, and then you do the password twice, that will hash the password before it goes into the audit log, and then it will store a hashed version of the password. People hate the older hashing algorithm, the MD5. If you're on an older version of Postgres, or you had your roles created prior to like Postgres 13, you might want to make sure that you're using the modern hashing for your password. The MD5 is generally considered to be like less secure. And lots of folks do some kind of single sign-on with Postgres. So if you're using like Active Directory or you're using something else, you can, most people are super secure. There's lots of encryption happening, especially if you're using the modern versions of this. There used to be people that use the LDAP, but most people don't like it, and with Postgres, the Kerberos is what modern people will turn to. And then if you're using some kind of cloud, so if you're on, Amazon RDS, or you're using Crunchy Bridge, you want to make sure that you have some kind of multi-factor authentication, right? Some way to make sure that people are who they say they are. We have a lot of people that have these big cloud databases, and if you're not doing some kind of multi-factor authentication, all it takes is one stolen account password, and you can get access to hundreds and hundreds and thousands of databases. When I talked earlier today about the Snowflake attack, that's actually what happened with the Snowflake attack. They have kind of already come out and said the way that this happened is they had several clients that were not using multi-factor authentication. They had a consultant that had a password breach, and that consultant had access to, I think, like 200 or 300 client sites, and that's how people were able to gain access to lots and lots of data for some of the United States' biggest data storage people. So big picture in terms of reviewing user access security, principal, least privilege, some kind of role-based authentication, give people the roles that they need, utilize the Postgres features like schemas, like tenants, like row-level security, like use things that are going to separate the data and make it so that people can only access the things that they need. Audit user behavior, use /password, Use Kerberos if you want single sign-on, and if you're using any kind of cloud, make sure you have multi-factor authentication. So one cool thing I want to mention, sort of as I wrap up, is that you're not completely on your own with this. There are a couple ways that you can actually get some help in going through your Postgres database to make sure you've met and kind of handle all of these issues. There's a security benchmark for the security of internet security. It's called a benchmark, but it's not a benchmark in the traditional performance benchmark. It's actually a security protocol. And they publish that with every version of Postgres that comes out. Crunchy Data partners with the CIS on this. I just published a blog actually on the CIS checklist. It's free to use. You do have to give them your email address. But it's like a 200-page PDF. It's got a lot of cool stuff in it. A lot of the stuff that I've covered in this talk, and it kind of helps you just go through your database and make sure you've got kind of everything buttoned up. So if you're curious about a security checklist, check out my blog, and then from there follow the links to the actual documents. There's also a security technical implementation guide for Postgres that's published by the United States Department of Defense. That's the government entity in the US that controls all of the departments of defense, like the Navy, the Army, Air Force, Space Force, all of that stuff. And Crunch Data partners with the Department of Defense to write the Postgres STIG. And it's very similar to the CIS benchmark. It goes through all of the things that I've talked about, like access control, encryption, role-level security, things that you should have in place for monitoring, things that you should have in place for auditing. That's also open and freely available if you want to read through the Postgres STIG. It's something you can download and read. We do a lot of penetration testing at Crunchy Data for the products that we sell, including our cloud product. And then prior to being at Crunchy Data, I work in consulting, and so I've been through several different rounds of penetration testing. If you're working on an application or a database, this is a great way to have a third party come in, run a bunch of tests against your database, and see kind of where you need to improve things. Even if you're not directly involved in the penetration testing, like let's say your company is having a pen test done on the application that you're on the data analyst team, get access, ask to read the pen test reports. I read the penetration testing reports every year that we have done. I'm not directly involved in securing anything in our cloud infrastructure. All of our engineers are doing that, but the penetration testing reports are always really well written. They're extremely informative. The companies that provide these know so much about security, and they're a great resource. If you have one done, they're a really good resource for your team to learn about security and how security is affecting your application and your database. There's also the SOX 2. That's another security program. That's primarily was originally developed in the US for accountants. You might hear about this, especially if you're making software that's going to be used by finance, by healthcare groups. You have to get certification, but there's a bunch of steps that you have to go through with kind of securing your application and your data audit to make sure that you're SOC 2 compliant. And so there's different types and kind of a whole world of compliance there, but that's another kind of layer of how a third party can kind of go through and do an audit of your entire security. Yeah, that is